Today we are going to have a small demo about this transformer and how this transformer is connected with equipment grounding as well as system grounding. So this is called as an transformer. Transformer is an static device. That's why for this device or this equipment we have to provide grounding. So in our subject you have equipment grounding and system grounding. What is the difference? Here only you get the clarity, okay. And here also one grounding is there where this is called system grounding, okay. So what you get the neutral to your home, this is nothing but this one only, okay. So this is nothing but two types of earthings are there, okay. Let's try to segregate it in clarified. So let's come to this transformer. So this is a transformer make 5 kilosquare. So you have an input line, okay. So you can see here there is the input line, okay. From that input you are going to have an HV line. So input is an high voltage. You can see the voltage at high voltage is approximately 11 kV, 11 kilovolts. Input is an high voltage. Voltage is high, automatically current will be lower. So input current is 11 kV and current is 8 amperes. Since current is 8 amperes, you see the fuses are very thin. Why? Because the maximum withstand capability is 8 into 1.5. 8 into 1.5 means 8 plus 4, it's how much? 12 amperes. Maximum it can withstand a maximum current of 12 amperes. Input voltage is how much? 11 kilovolts, but current is how much? 8 amperes. So on our average and full load also it can take only 12 amperes. So from input we are getting through arc, this is called arcing horns where we can act like an lightning arrestor, okay. So we are giving the input to the transformer and you can see here we are going to take the output. So this is nothing but output of the transformer. So this is an oil cooled transformer, okay. So a transformer in detail we will discuss later. So you can see here, so there you have an underground cable. From underground cable we have an changeover switch. From changeover switch we have an thin wires where this nothing but current is 8 amperes and we had applied the 3 phase to the input of the transformer. So the output of this we are having an underground cable. So now coming to the output voltage, you can see the tabular column, the output voltage will be an 213 volts where this is nothing but the phase voltage. Line voltage will be 420 or 420 volts and maximum current it can withstand is 213 amperes current. You can see the current rating. So it can withstand a current of 200 amperes, okay. What is the voltage rating? 3 phase is 420 volts, okay. So generally what it will be specified here is only the line voltage. Line voltage is 415 or 420 volts and maximum current is how much? 213 amperes, okay. The output of this transformer we can connect up to 213 amperes, okay. So when you do the product, automatically we can find out the rating of the transformer. Transformer rating will be in terms of what? kVA. So you can see if you multiply both, the rating of this transformer is 160 kVA, product of voltage and current. Here power factor we are not going to take into load. Why? We don't know what kind of load we are going to connect. For example, sometimes they may connect inductive load, sometimes they may connect resistive load, sometimes they connect capacitive load. Based upon the load, it may be an resistive or it may be an inductive or it may be an capacitive. That is why load is not known. The transformer manufacturer will develop only what? kVA, okay. So I think you can say this is called bushings. So you have, and these are called porcelain. So why porcelain is used? You know the logic. So 3 phases are brought together, okay. If they are brought together, automatically arcing may create. So inside you have the winding and it may create an arcing. To reduce that arcing, to reduce this interference, and porcelain type of insulation is provided, okay. So this will reduce the arc produced between R, Y, B. Why? Because while they are entering, so while they are entering they are working very closer. As soon as become closer, it is like short circuiting R and Y. If you make them very closer, what will happen? Arc will develop. Why? Because potential difference is higher. To reduce that arcing phenomena, an insulation is provided. So this porcelain will act like an insulator, and these are called as, I think, got always studied in the transformer. This like an breather where we have a silicon crystals where it will absorb the moisture, and the top mode what we are going to have is nothing but an conservator tank. So through conservator tank we have an book hose relay. It will try to maintain the required pressure in the tank as well as in the oil. It is like an like conservator means like an balancing. So whatever the oil is required, it will try to balance and it will take the required amount of it's like absorb the moisture from the air. Sometimes in the winter or in some winter season, moisture will be there at outside, that should not directly go into the transformer. The moisture is filtered out using an silica gel crystals. So this is like an overall view. Now coming to the earthing, so we will discuss you earthing. Here you can see here you have an equipment earthing and this is called system earthing. So that is what there in our syllabus. So this like if you discuss equipment earthing separately, system earthing separately, transform is separately, it is not a meaningless subject. So all are integrated in practical system, all are integrated, all will try to work as an same. Okay. So now sir will help you to understand about what is system earthing and equipment earthing. Okay.
నేను జనాలకు చెప్పాను నేను ఇంగ్లీష్ అన్నట్లు ఏమన్నా సో వాళ్ళకి అర్థం అవ్వాలి కదా, కాన్సెప్ట్ అర్థం అవ్వాలి కాబట్టి స్ప్రెడ్ అవుట్.